Very warm welcome to this session on multiple regression analysis with SPSS. Before we proceed towards SPSS, let me introduce some basic concepts. First, what is multiple regression analysis? According to Griffith, regression analysis is about predicting the future, the unknown, based on data collected from the past, the known. So there are two types of data, cross-sectional data and time series data, and both can be used in regression analysis. What is the difference between correlation and regression? Who, in their book, say correlation is concerned with the magnitude and direction of relationship, whereas regression focuses on the rise using the relationship for prediction. What are uses of regression analysis? There are several uses. For example, if you want to forecast sales or revenue or demand or anything else, you can use it by using either cross-sectional data or using the time series data. You can also use regression analysis for finding out the determinants of variables such as attitude, behaviors, task performance, work performance, job satisfaction, or any other variable which you want to measure. Then it can also be used to determine factors which affect effectiveness of a program. You can use it in program evaluation and some other purposes also. What is simple regression? Simple regression is also called as bivariate regression. The reason is that in this case there are only two variables. One is the dependent variable and second one is the independent variable. Dependent variable is also called as outcome variable, whereas independent variable is also called as predictor. So a very basic equation we use in simple regression is y is equal to alpha plus bx. Here, y is the dependent variable, a is the intercept, whereas b is the coefficient of x, x is the independent variable. In other words, how we interpret these two values, the parameters, the a and b. A is the intercept, means it is the value of y when there is a zero value of the independent variable. What is b? B is simply rate of change in y per unit change in x. This is very simple concept of beta coefficients. What is multiple regression? In multiple regression, we have more than one independent variables, whereas only one dependent variable. So a very simple equation, we can use it as follows, like y is equal to alpha plus b1 x1 plus b2 x2 plus bn xn. Here in this case, we can use as many as variable you want, and every independent variable will have one coefficient that we call as beta coefficient. So in other words, so every beta coefficient will actually be measuring the impact of that variable in the dependent variable or its impact on the dependent variable. For example, beta 2 will measure the impact of x2 on y, and beta n will measure the contribution of xn in y, and so on. And what is R square? R square is also called as the coefficient of variation, and it measures the strength of the model. It ranges from 0 to 1. Higher the better. If it's closer to 1, that means strength is a very strong model, and if it's closer to 0, it means that is very weak model. How we interpret it? It in fact measures variation in the dependent variable explained by independent variables included in the model. For example, if value of R square is 0.45, that would mean 45% of the variation in the dependent variable is being explained by the independent variables included in that model. What is adjusted R square? A very simple rule is when you increase the number of independent variables, R square tends to increase. Hence, there is always a chance that some irrelevant variables may boost the variable, artificially increase the value of R square. So we need some adjusted R square. So what is adjusted R square? It is also a measure of the coefficient of variation, and it's adjusted on the basis of number of variables and the sample size. Then another term we use in regression analysis, it is F statistics. F statistics is used to measure the overall significance of the model. Here in this particular case, we just examine the p-value. If p-value is less than 0.05 or even 0.05, we say model significance is there. If it's not less than 0.05, it's more than 0.05, so we don't proceed further. So that means model is having some problems. Intercept, I have already explained you that it is alpha, so it is simply a value of dependent variable when value of independent variable is 0. This is a very simple concept from the perspective of a layman. Then beta coefficient is a measure of change in the dependent variable or unit change in a certain independent variable. That is beta 1, beta 2, beta 3, beta 4, and on and on. Now let's proceed towards the SPSS. So here is the our data. The performance is the dependent variable. Work environment, supervision quality, work-life balance, ICT, and HRD. Here in this case, I will use only two variables. One is the work environment, and the second one is the supervision quality. These two variables I will use as independent variables and performance as the dependent variable. So go to analyze, then regression. Here linear, and so you see here the first box is for dependent variable, and this second box is meant for independent variable. You can add here as many as independent variables you like to include in the model. Like here in this particular case, I'm going to include performance as a dependent variable, and work environment and supervision quality as the independent variables. So these are my predictors. So performance is my outcome variable, right? So let's click it. Okay. So it's running. So there are some other options also, but I'm not going to use the other options. So here in this particular case, you see here, these are the results. The first table shows the description of variables. So you see here, the dependent variable is performance, and the other variables like supervision quality and the work environment, they are the independent variables. Then come to second table. Second table is model summary. Here you would see, so we have the values of R and R square, then adjust R square. First look at here, R square. R square value is 0.28. So that means 28% of variation in the performance is being explained by this model, mean these two variables. And adjusted R square is 0.269. So that's not much different from R square. So if we say, we can conclude that the variables are fine, they are appropriate. Then come on to ANOVA. Here you will see here is the F statistics and significance. So since it is less than 0.05, so we say the model significance is established here. The last table here, so this is the coefficients. So here in this particular case, you will see uh, uh, here is the beta values. It is the beta also, but the difference between the two is the first one is unstandardized beta, and here it is the standardized beta. The next column is the t statistics, and last one is the significance. Let me first talk about the first one. So that is the work environments beta 1. So beta 1 is for work environment, so that is 0.56. How we interpret it, we say if one unit work environment is improved, work performance will increase by 0.564 units. And as far as supervision quality is concerned, so here we say, since it's also positive, and it's also positive, so we say every 1 unit increase in supervision quality will bring an improvement in the performance by 0.478 units. Right? So standardized beta is used to compare the contribution and impact of the independent variables. So here we see 0.64 and 0.4. So mean supervision quality is having a bigger impact on the performance than the work environment. However, we are yet to decide whether this impact variable, work environment, and I or the supervision quality or both, they are significant predictors of the performance or not. Uh, Means they are statistically significant predictor or not. So we look at the t-values. If t-statistics increases 1.96, that means so it is a significant predictor. So we see in both cases it's far greater than 1.96, and significance value is also far less than 0.05. So we find that both of these variables, they are positive and significant contributors towards performance. So they are significant predictors of performance, more simple words. If hypothesis was like this, work performance is a significant predictor of performance, so we will accept this hypothesis. If supervision quality is related hypothesis was that supervision quality positively affects performance, so we accept this hypothesis also. So on the basis of this particular table, also we can accept or reject the hypothesis. So this was the very basic level understanding about regression analysis. Thanks for